Okay, so today we're going to talk about solving linear equations again. So first, let's review from last class on Wednesday. So a solution to an equation is a value for x that will make the equation true. Una solución a una ecuación es un valor para x que hará que la ecuación sea verdadera. No. ¿Verdad?
Verdadera.
Verdadera. Okay.
Sí.
It's a lot of syllables. Okay. So the value of the left and right side of the equal sign should be the same. That's how you check to see if you found a true value. El valor del lado izquierda y derecho del signo igual debe ser el mismo. Okay. In our last class, we saw how to find solutions using the table and the graph representing a linear function. This is from our last class. Right, we looked at the equation x minus 2 equals 5. Right, on the table, we see the solution in the box here. Right, and we see that x minus 2 equals 5, where x equals 7. So 7, x equals 7 is the solution. On a graph, we see that y equals 5 here. Right? Y equals 5 here, and we follow that over to the graph and follow that down to the x-axis, and we see that x equals 7 at this point on the graph where y equals 5. So again, we get x equals 7 as the solution. So we can use a table or a graph to find solutions. Today, sorry.
So, Mr. Mosley, I just wonder if anyone has any questions. Does that, just to see if anyone...
Yeah.
Does anyone have any questions, or does that sound like you understand what that was all talking about? So I guess since I don't see anything in the chat, so maybe everyone everyone's clear on that then.
All right.
Okay.
Okay. All right. So today we're going to look at how to solve a linear equation algebraically. We're going to follow these steps when solving our linear equations. Right. Step 1, we simplify each side of the equation by removing parentheses and combining like terms. Huh? Yeah.
Okay. Los pasos para resolver ecuaciones lineales. La número 1, simplificar cada lado de la ecuación al remover los paréntesis y combinando términos iguales.
Then step 2, use addition or subtraction to isolate the variable term on one side of the equation.
Número 2, usar el método de adición o de resta, de suma o de resta, para aislar el término de la variable en un lado de la ecuación.
Step 3, use multiplication or division to solve for the variable.
Usar la multiplicación y división para resolver por la variable.
One note, fractions may be removed by multiplying each side of the equation by the common denominator.
Y como nota, nos dice que las fracciones tienen que ser removidas al multiplicar cada lado de la ecuación por un común denominador.
Okay. So these are the steps. that we're going to use. We're going to look at a lot of examples today. I'm going to show you a lot of math. I encourage you to take notes and follow along with the examples so you can look back at them later. It's going to be a lot of math.
I did not see the translation in Spanish in the bottom.
I was trying to be prepared today. Well, I felt like it would be helpful because I do post the notes into Canvas later, like to have both for them if they want to look back at it. Okay. Primero, we have one-step equations. So we have some examples here. We're going to do a lot of math today. It's going to be very exciting for me. I love doing math. Hopefully you guys enjoy it too. Okay, so for the first example, we have 26 equals 8 plus v. Okay, notice the variable in our examples is not x, and that's okay. Right. This one is v, p, b, n. I don't need to always use x for the variable. I can use any letter for a variable. Okay. So in these examples, they're using different letters, and that's okay. The only letters you don't want to use are E and I, because they have special meaning in math. So you don't use those ones.
Nice. Ok, muchachos. Una nota muy importante aquí es que cuando estemos haciendo ecuaciones en general, pero en este caso ecuaciones de un paso, pueden usar cualquier letra del alfabeto, cualquier letra como variable. Pero hay dos excepciones. Nunca pueden usar la E, o bueno, no pueden usar la E y no pueden usar la letra I, porque esas dos letras son usadas para términos diferentes en matemáticas. Van a usar cualquier otra letra excepto la E y la I.
Yeah, they don't need to worry about what those are at this point, but yeah, they have special meaning. So, okay, número 1. 26 igual 8 más v. Okay.
We have a question.
Oh yes, Sean.
Mister,
Sí.
¿qué pasa si ponemos la I y la E?
You want to know what they are?
Yeah.
So, okay, how do I explain this? Don't write this down, guys. This is not part of the notes for today. All right, the letter I is equal to the square root of -1. It is called the imaginary number. Okay, so the letter I is equal to the square root of -1, which in normal mathematics doesn't exist. But when you get into, you'll see this in Math 3. You'll see the letter I, right? It's called the imaginary number. It is equal to the square root of a -1. E, I don't know what's the best way to explain this. I'm trying to remember. E represents the natural log, which again we aren't going to get into. What is my E on this calculator? There it is. It's approximately 2.718. And the E is essentially, oh man. It's going to be really hard to explain for our class.
Okay.
The natural log of E equals 1.
Okay.
doesn't help or anything, but E represents that 2.718. It allows us to do other calculations in mathematics having to do with exponential functions and logarithms, which we're not going to get into right now. But yeah.
Okay. Thank you, Mister.
You're welcome, Sean. Okay. So again, that's why we don't use them as variables. All right. Okay. Now, back to número uno. So for this equation, these are one-step equations. All right. I'm going to be adding or subtracting to get to the solution. I don't have parentheses, right? I don't have like terms. So I'm just adding or subtracting. So our first step here is I need V by itself. Okay. So this, we're using step 2. Okay. We're using addition, la suma, to get the variable on one side of the equation. Okay. So now we need to subtract 8 from both sides of the equation. If I subtract the number from one side, yes, Damien, very good. I have to subtract that same number from the other side. Right? That makes this number go away. Cancels out. 8 minus 8 is 0. 26 minus 8, as Damien said, and Anise said, is 18. Which means 18 equals V. And that is our solution. That means if we check this work, when I replace V with 18, I should get 26 as the result. We see 8 plus 18, right? And that equals 26. Everything works. Okay.
Mr. Mosley.
Yeah.
Itati is trying to join the meeting again.
Mm-hmm. I think I let her back in already.
Oh, okay.
Yeah, she's in a. Yeah.
Okay, thank you.
All right. Mm-hmm. So, número 2. 3 más pi igual 8. Para el primero paso, necesito resta 3. ¿Ok? Porque es positivo 3 a la izquierda de igual. So, menos 3 y menos 3 a derecha. 3. I want to make sure I'm saying right. Where's right? How do I say right hand side? I don't know. I'm sorry. So 3 minus 3 gives us 0 plus p. 8 minus 3, 5. And p equals 5. Right? And then we check our work. I know it seems silly, but we always want to check our work. 3 plus 5 equals 8. Woohoo! Okay.
So, Mr. Mosley, if they're like obvious answers, you still want the students to show their work as you're doing right now?
To be honest, I don't
Yeah.
care if
Okay.
they show their work or not for these types of problems.
Okay.
They need to know how to check. That's why I'm showing it.
Okay.
For these basic examples, it seems like an unnecessary step. But when we do these ones, it will be necessary.
Okay, so you just kind of want them to get in the practice of
Yeah, it's
what they're
just
doing.
building the habit, so I'm modeling it. Yes,
Okay,
so to
sounds
say.
good.
And yeah, like Damien and Aaron, you say like they're busting through these one-step equations because they're you can look at some of these and be like, oh well, to get to 23 from 15, I add 8, so b equals 8. There's not a whole lot of necessary mathematics, but we're building the habit of how to solve an equation. We're practicing with when we're starting very simple and adding extra parts along the way as we go to the two-step and then multi-step. So I'm showing all the steps and I'm showing all the work so that things aren't missed because everyone's in a different place of understanding. So.
Sounds good. Yep.
Yeah. All right. Número 3. 15 plus b equals 23. Our first step, we have a positive 15 over here. I need to get rid of it by subtracting 15 on the left-hand side. Then I have to add 15 to the right-hand side. All right, what am I doing? See, I'm talking too much. I'm making mistakes. Minus. Lo siento. Perdón. All right, 15 minus 15 goes away. It's canceled. B equals 23 minus 15, 8. And we want to check our work. We have 15 plus 8 equals 23. Hooray. Yes, Shanley, excellent. Right. Our next one, right? We have negative 15 plus n equals negative 9. Right? I need n by itself on one side. So I'm going to get rid of the number that's over here with it. So to do that, I do the opposite of subtract, which is add. Add 15. Minus 15 plus 15 is 0, so it goes away. N equals negative 9 plus 15, 6. And again, we check our work. We have negative 15 plus 6, because 6 is now the value of n. That equals negative 9. Okay. We want to check our work because we need the habit of not just assuming what we did was correct every time. The most common mistakes in math from high school through college is making an addition or subtraction error. I know it sounds silly, but that is one of the most common things that happens in any level math class, is making the kind of error I did with question 3 where I started to add 15, and maybe if I don't catch that because I'm going too fast and I'm moving on, I made a big mistake and I didn't see it. It's not that I don't know how to do it, I just made a mistake, but I didn't check my work, and then maybe I don't catch the mistake. So we check to have the habit of always checking our work. Okay.
Cuando estén resolviendo por estas operaciones, muchachos, tienen que tener mucho cuidado y poner mucha atención con los signos. Porque el maestro le estaba dando un ejemplo. Él nos dijo que les estaba dando un ejemplo en el que estaba, en vez de restar el número 15 en el ejercicio 3, él estaba sumando 15. Lo contrario a lo que debería estar haciendo. Entonces tienen que tener mucho cuidado. Tienen que verificar antes de resolver cuál es el signo que deben utilizar. Si cambia del signo igual, si cambia de un lado hacia el otro, verifiquen cuál es el signo que tienen que usar. Pasa de sumar a restar, tienen que asegurarse que tengan el signo de menos.
Yep. We have to be careful. All right. Well, any questions for our one-step equations?
¿Preguntas para este tipo de ocasiones, muchachos? Cualquier pregunta, ninguna pregunta es innecesaria. Todas son importantes.
I wish all of math was this easy.
All right, here's the secret. It is. There's just more steps involved. Everything goes back to these like, what I tell everyone, all of math goes back to adding, subtracting, multiplying, and dividing. It just gets more, you have to do more steps to get of that over and over again. But it all goes back to the basic 4 operations. You know, coming from a guy with a math degree, but still. All right. So, 2-step equations. All right. So on this first one, we're going to start in our steps on step 2. We're going to be adding or subtracting, but then we're also going to have a multiplying or dividing as a next step to get our, to solve for the variable. So we're going to start by subtracting 2 on this one from each side. Okay, I need A by itself. So I subtract 2. I have plus 2 minus 2. Cancels. 6 minus 2. 4 equals A divided by 4. All right. Esta línea aquí es dividir. Okay, it means divide. A divided by 4. Okay. So the opposite of dividing is multiplying. So to get rid of 4, A divided by 4, we multiply by 4. Okay. And so if I have a number in parentheses next to another number, that means multiply. Almost. Good guess, Amy say. All right, so when I have A divided by 4 times 4, the 4 goes away. 4 times 4, 16, equals A, right? When I multiply by 4, I'm only left with A on the right side. 4 times 4 is 16, so 16 equals A. Now we check. So where we have A, I replace with 16. We have 16 divided by 4 plus 2. 16 divided by 4 is 4 plus 2 equals 6. That's what I wanted. Perfecto. Okay? So again, this is why we check. Anytime you think you have a solution, you have to check. That is how we find mistakes. So, what questions do you have on this one?
Muchachos, ¿todos entendieron el problema? ¿Saben cómo resolverlo? ¿Saben qué es lo que cambió en este problema? Escríbanos por favor o díganos. Damián.
Okay, so Damien says he more or less gets it. And Chandelier wants to know, how do we check again? So when we check, right, when you check an equation to see if you're correct, right, in this case, like for this problem, I need this side, right, a divided by 4 plus 2. Okay, so Christian, that's what we're talking about right now. En la parte donde está el check. Okay, so this, when I put in my new value for a, which is 16, needs to equal 6. Okay, so el lado derecho, necesito igual 6 cuando a igual 16. Okay, porque 16 es la solución para esta ecuación. Okay, so yo necesito I don't know how to say replace.
Reemplazar, sustituir.
Reemplazar.
Ajá.
Okay.
Yes.
Reemplazar. Okay. So yo necesito reemplazar a con 16, porque 16 es la solución para esta ecuación. So en el check, no usar a, usar 16. Okay. So this was a, now it's 16. Right? 16 dividir 4 es 4. 4 sumar 2 es 6. 6 igual 6 y check. Okay.
Leon doesn't understand the how to solve the equation. Leon, ¿no entiendes cómo resolver la ecuación o cómo hacer el check? ¿Cómo comprobar la ecuación? ¿Cuál de las dos partes? ¿O todo? So, Marley, would you like me to repeat what you said, the explanation?
Yeah.
Go over that. Yeah.
Yes.
Muchachos, vamos a repasar bien breve, ¿ok? Recuerden que si queremos resolver por una variable, el check, ok, muy bien. Entonces el check, cuando ya tenemos la solución, cuando hacemos la ecuación y nos da la solución, el resultado de A o el resultado de cualquier variable, en este caso A es igual a 16. Entonces para hacer el check, tenemos que sustituir el 16 en la ecuación, en la variable de la ecuación. Por ejemplo, si tenemos A es igual a 16, tomamos ese 16 y lo sustituimos en en la variable de a en la ecuación original. Entonces, nos tiene que dar 6 de los dos lados. Vamos a poner 16 entre 4 más 2. Dividimos 16 entre 4, nos da 4, más 2 nos da 6. Entonces ya sabemos que al sustituirlo, si nos da el mismo resultado en ambos lados de la ecuación, es así como sabemos que la solución a esa variable es correcta. Entonces sabemos que a es igual a 16 porque sustituimos y nos dio el mismo número en ambos lados de la ecuación. Entonces es correcto.
Gracias, Mr. Morales. Okay.
Those fractions are like make things so much more difficult, you know. That's what I think.
I know. I totally get that. This is so I'm glad you bring up the fractions. Fractions, most students don't like fractions because they don't look like regular numbers, right? So, like we know, 1 entre 4 es igual a 0.25, ¿sí? Pero usualmente los estudiantes prefieren 0.25, es el número, es el décimo. Pero en matemáticas, the fraction, right? 1 entre 4 es más I don't know that I can't say this the way that I want to say it in Spanish. It's more usable as a fraction because this 1 entre 4 tells me what to multiply by to get rid of the fraction. The decimal does not.
Okay, entonces, that's I learned something new, or at least I can see it clear.
Yeah.
Entonces, muchachos, a veces las fracciones les puede resultar un poco más complicadas porque, como dice el maestro, los normales o números que usamos usualmente. Entonces, depende de la situación, se van a hacer fracciones o decimales. Por ejemplo, un cuarto se usa más o es más conveniente cuando, bueno, nos dice qué es lo que tenemos que multiplicar para deshacernos de la fracción, para obtener un número entero o un número decimal. Por otro lado, nosotros usamos normalmente los números decimales como para decir centavos u otras expresiones.
The fractions, like in a lot of math, they're just easier to use because they tell me more information over just a decimal. So, anyway, but yeah, I know fractions. A lot of people are very uncomfortable with fractions, and that's normal. That's typical. And so we just need to practice with them to get more comfortable. So let's look at our example. All right, número 2. We have negativo 6, sumar x entre 4 igual a negativo 5. Okay. El primero paso es sumar 6 a dos lados. Okay. So we have más 6 menos 6 sumar 6, 0. Y x entre 4 y igual. Negativo 5 más 6 es 1. Okay. So it's a good guess, Anthony. But we have one more step. Uno más paso. Okay. X entre 4 igual 1. Okay. So, ¿cuál número por X cuando su dividir de 4 es 1? Yeah. Eunice says it's 4, right? 4 divided by 4 is 1. But to show the step, right? If I divide by 4 to do the opposite, I multiply by 4. And I multiply by 4 on both sides. Right? When we have 4 times x divided by 4, the 4's go away. Then we have 1 times 4 over here, which means all I have left is x equals 4. And then we check. Okay, so I put wherever there's an x, I put a 4. We have minus 6 plus 4 divided by 4. Because I have one x. Negative 6, 4 divided by 4. 1. Negative 6 plus 1. Negative 5. And that's what we wanted. I needed negative 5 as the result. Okay. What questions do you have?
I guess it's kind of important when you have like 4 over 4 to remember that's a 1, not like canceling it out and it's a 0.
Correct.
Yeah.
Yes. So to put a little more into what you were saying. So when we do, I'll repeat the check. Give me just a second. So when we do this step here, and I multiply by 4, right? I'm going to bring this out here so we can look at it. We have 4, right? Times x over 4. When I do this, what's actually happening is I end up with 4 times x over 4, which is the same as 4 divided by 4 times x, which is 1 times x, which is 1. So they're not equal to 0. Like when I have these 4's and they cancel, right, it's not because it equals 0. It's because 4 divided by 4 is 1. And so I have 1x on the left-hand side, which is what I needed. I need x, just one of them. Okay, and so then when I do the check, right, I said, okay, x equals 4. That was my solution. So to check the solution, everywhere in the original equation that there was an x, we replaced with 4. So this was an x here. I replace with 4. So we have minus 6 plus 4 divided by 4 equals negative 6 plus 1 equals negative 5. Negative 5, right, is the solution that I needed to start. Okay. Yeah. Does that help? That was a lot. Okay. All right. There, let's look at another example, guys. Let's see what else we got here. So number 3, we have 9x minus 7 equals negative 7. Okay, so our first step, do the plus 7, right, so that I can remove the minus 7 that's attached to my variable. Let's go away. Right, this equals 0 here. We also get 0 over here. 9x equals 0. To undo or reverse multiplying, I have to divide. So this is 9 times x. To get rid of the 9, I divide by 9. Zero divided by 9 is still 0. And then you check. So everywhere there's an x, I replace with 0. 9 times 0 minus 7. 9 times 0 is 0 minus 7. We get negative 7, and that was the result that I needed. So it works. Okay. What can I clarify? What can I help with? What questions do you have?
So anytime you have a 0 above any number below, the answer is always going to be a 0. Is that right? Like, could it
be 0 divided by anything besides 0. That's a whole different argument if you're doing 0 divided by 0. We're not going to get into that. That's a deep mathematical discussion.
Yes.
But 0 divided by any number besides 0 is 0. If I have 0 things and I divide it, 9 ways, I still just gave everyone 0 things. So yeah, 0 divided by any number besides 0 is 0. You are not allowed to divide by 0, ever. My professors used to joke that if you divide by 0, you end the universe. So don't divide by 0. It's not possible.
Well, we can't have that.
Yeah, dividing by 0 is not allowed.
Okay.
At least not on days that end with y.
Thank you.
You're welcome. Oh, math humor. Okay.
Did we answer Damien's question?
As far as I know, yes.
Okay.
He asked me to repeat the check for question 2.
Okay.
I Yeah.
Okay.
All right. Last example, number 4 for our two-step equations. We have 0 equals 4 plus n divided by 5. We're going to start by doing some subtraction so that the 4 over here gets removed. So we do minus 4, minus 4. We get negative 4 equals n divided by 5. Right. We have to now do the opposite of dividing, which is multiply. And we multiply it by 5 on each side. Yes, Eunice, you are correct. Okay, so we have these 5s go away. I'm left with n. 5 times negative 4, negative 20, equals n. And yes, we are going to check. So everywhere there is an n, I put in negative 20. So we have 4 plus negative 20 divided by 5. That will equal 4 plus negative 20 divided by 5 will be negative 4. 4 plus negative 4, 0. And that is what we needed. Okay. Is there any questions before we move on to multi-step equations?
Preguntas, muchachos, preguntas. Creo que esta ecuación estuvo un poquito más complicada o más tediosa, pero si tienen preguntas, déjenos saber.
Okay. All right. So now, multi-step equations. These are a little bit more interesting. In math, we like to say things are more interesting when they get more difficult. Why does the 5 and negative 4 go on the left side? Okay. Let's look at that. So over here, on the right-hand side, I multiplied by 5, right? That was this 5 here. Since I multiply by 5 on the right-hand side, I also have to multiply by 5 on the left-hand side. The negative 4 was already here from 0 minus 4. We have the negative 4. I put the negative 4 in a parentheses to show that it's being multiplied by this other number. If I don't have the parentheses, it just looks like 5 minus 4, which is not the correct operation. So that's why I have the 5 and the negative 4 on the left-hand side. The negative 4 just comes from here. It goes into the next step from 0 minus 4. And the 5 is from multiplying each side by 5. Does that answer your question, Shanley? Maybe. You're welcome. Okay. In our multi-step equations, we have what are called like terms. Right. We see this in the first example here. On the right-hand side of the equal sign, we have two terms that both have the variable x. Since they both have the same variable, I can combine those into a single term. Right. To do that, what we do is we take the number next to the variable for each of the like terms. So we have a -4 and a -6. We put it in the parentheses here with the variable to the outside of the parentheses. All right. And then in our next step, notice this -20 is just moving with us to our next steps. We do what's in the parentheses now. -4 minus 6. Is -10. So the combined term from our -4x minus 6x is -10x.
Now, why didn't you multiply those?
Why didn't I multiply 4 and 6? The -4 and -6?
Yeah.
Because the operation between the two like terms is subtraction.
Okay.
We have -4x minus 6x. So the operation goes with the coefficients, right? The numbers next to our variables. If I had -4x times -6x, that would be a different thing.
Okay.
And that would be, if I was multiplying, it would be written with that parentheses.
All right. Perfect.
Which is why in the previous example, I made sure to put the parentheses around the -4.
Okay. Yep.
Yeah.
Thanks.
Yeah, we're not ready to do the multiplying stuff yet because that results in a different type of equation that we're not doing yet. All right, so we now have -20 equals -10x. Okay, so I have -10 times x. So to reverse that and undo the multiplying, we divide by -10. Since I'm multiplying by -10, I divide by -10 to get rid of the multiplication. Those go away. We get -20 divided by -10. 2 equals x. And then we need to check it. All right, and I'm going to do my checks over here because these questions are closer together. So everywhere I see an x, I'm going to put a 2. So I have -4 times 2 minus 6 times 2. Right, so the 2's come from here, saying it's equal to x. In my original, these were both x's, so they get replaced with the 2. -4 times 2 is -8, minus 6 times 2, which is 12. -8 minus 12, -20. So it works. Okay. In this next example, we have like terms that are numbers. We have a 1 and a +5, and in between we have this -2n. So we still need to combine our like terms. I have regular numbers, I can put them together. We have 6 equals -2n, and that's because this just goes into my setup for the next part. +1 +5. These are my like terms. We have 6 equals -2n +6. So now we have the equation set up. And we can solve. And we'll do our -6, -6. We have 0 equals a -2n. Divide by -2. We get 0 equals n. And we check number 2. Wherever there was an n, I replace with 0. So we have 1 minus 2 times 0 plus 5. 1 minus 0 plus 5. We get 6. Okay. Do you have any questions on these first two? Okay. All right. So on the last, we're gonna have number 3 here be our last one. I'm not gonna do number 4 just because of how much time we've been working already. So don't worry about number 4. In number 3, we have a variable, the same one, on both sides. Okay. So again, I need to get the variable term on one side and the numbers on the other side of the equal sign. Okay. So to do that, I'm going to subtract 7x from the right-hand side, which means I have to subtract 7x from the left-hand side as well. Es 11:55. We're almost done. We're doing this one last problem. All right. So I need to get my variable on one side, I have to subtract the variable term from the other side. So I've subtracted 7x here, so that goes away. 8x minus 7x will give me just 1x. And we see that as we have 8 minus 7 x, right? The minus 2 comes down from here, equals negative 9. 8 minus 7 is just 1, so I'm left with x minus 2 is negative 9. And I add 2 to both sides so that I can have x by itself. Let's go away. Negative 9 plus 2, negative 7. Now we need to check. And to check this, we have to check both sides of the equation. So we will start with the left-hand side. And that will be 8x minus 2. So where there's an x, I put negative 7. So 8 times negative 7 minus 2. That equals negative 56 minus 2 equals a negative 58. Then I check the right-hand side. And I have negative 9 plus 7 times negative 7. Again, this negative 7 goes into my equation where x used to be. We get negative 9 plus 7 times negative 7, negative 49. Negative 9 plus negative 49, negative 58. We got the same number from both sides of the equation, which means we found the solution. All right. What are your questions?